So if we were going to do the ammonium ion, who's got the highest combining capacity? Nitrogen, so it's your central atom. It's atom A. So nitrogen brings 5. Hydrogen brings 1, and there's 4 of them. The plus charge means you've lost an electron. So we're going to subtract 1. So we actually have 8 electrons. No matter which method you use, I want you to always show the number of valence electrons somehow. Okay? If you're choosing this method, the old method, you do it like this. Don't skip this step. You skip this step, you lose electrons, you miss something. Now you've screwed up your Lewis structure. Now you've screwed up your Vesper shape and your Vesper name, and you've got no marks. Don't take shortcuts. So 8 electrons, you've got 4 hydrogens. So you place your hydrogens. I've used up how many electrons? 8, because I've got 4 bonds containing 2 electrons each. I have no more electrons. I'm done. Except if you have a Lewis structure, you have to put your square brackets and your charge. If it's 1, you don't actually have to write the 1. You could just put plus.
Nitrogen usually forms 3 bonds, but so then when it does form 3 bonds, it has an extra lone pair. So when like a H plus comes along that has no electrons, it just bonds with those 2.
What do we call that type?
Coordinate
Covalent bonds. Okay, good. Coordinate covalent bond is when your bonding pair of electrons comes from one atom. It donates both electrons. When you draw a Lewis structure, we don't show them as being different at all. It's just another covalent bond. Okay. Okay, so sulfur brings 6. Hydrogen brings a total of 2. We've got 8 electrons. You put in your bonds. There are no electrons to place around my terminal atoms. So we're on step 4. It says, put them around the most electronegative atoms left. If there are more than enough, add the extras to your central atom. So I've used 4, so I have 4 left. To complete sulfur's octet, they go on the central atom. Okay, straightforward? Okay, carbon dioxide.
Where did you put the electrons, like on the coordinate band?
I didn't for this. I didn't for this, but normally, yes. Thinking ahead. CO2. Carbon brings 4, and 2 oxygens brings 12, so we've got 16. Carbon is the least electronegative. It's got the highest combining capacity. It's going to go in the middle. Forget for a minute that you know what the structure looks like. So we're following the rules, because you're going to be doing structures for things you've never seen before. So oxygen is the terminal atom. Because there's 2 of them, an even number, I'm just going to spread them as far apart as possible, because electrons like to be as far apart as possible. So I've used up 4, so I have 12 electrons left. So I've done step 3. Step 4, now I'm going to put them around the oxygens, the most electronegative ones. So you're going to put them around your terminal atoms first to complete its octet. All right, I've put them in. I've used up 2, 4, 6, 8, 10, 12. I've got none left.
Yeah, but
Wait, what?
carbon doesn't have
What?
complete octets.
Correct. What do you mean, what? Where are we?
Number 5 says if an atom has an incomplete octet, convert lone pairs to convert them into
Yeah. What's your what for? Right? We've got 2 there, 2 there, 2 there, 6. 2, 4, 6. We've used up our 12. Oxygen here is surrounded by 8. This one's surrounded by 8, so they're both cool. Carbon, not happy. It's only got 4. If you're short electrons, as in you've got no more to place, you've used up the whole bank, then you form double bonds. So you convert a lone pair to a bonding pair. So don't forget, this is like a potluck, right? You bring stuff, but you don't necessarily own it anymore. Once it's on the table, everybody gets to use it or eat it. Okay, so now we've got carbon with double bonds. So look at that. Carbon has a combined capacity of 4. It's made 4 bonds. Okay? So here we go. We've used 2, 4, 6, 8, 10, 12, 14, 16 electrons. Oxygen's happy. Carbon's happy. Oxygen's happy. Our structure is done. Right? Yep.
Why is it that carbon dioxide is like linear, but water is bent?
And it has to do with the fact that carbon, the central atom, has no lone pairs of electrons. Water has 2 pairs on the oxygen on its central atom. They actually take up more space than bonding pairs, so they push.
They push it down.
They're pushing those bonding pairs down. Yeah.
We have to show that.
T stands for total electrons wanted. So how many does it want altogether? This is where you're fulfilling your octets. Or hydrogen only wants 2. Boron only wants 6. Okay, so total electrons wanted by the atoms. V is the valence electrons brought. Okay? And then S stands for shared electrons. Shared electrons. So, if we were going to do this for CO2, how many does oxygen want to be surrounded by? 8. How about carbon? 8. So I've got 8 for carbon and 8 for oxygen, and there's 2 oxygens. So basically 3 times 8 is 24. Valence electrons. Carbon brings 4 and oxygen brings 6 for a total of 16 electrons. Now, if you subtract the valence electrons from the total that they want, that tells you the number of electrons that are shared. So I have 8 shared electrons, and they are shared in pairs. So if I divide by that 2, that tells me the number of bonds. So I know in my structure, I have to have 4 bonds. Who makes 4 bonds? So there we go. It actually basically gives you a big hint where to start.
So much easier.
Okay? Now, you still have to use this 16. I can't place more than 16 electrons. How many have I already placed? 8. So I've got 8 more to place. Let's fill up those octets on the outside. There's my 8. There's my structure. Okay? There's my 5th bond. Okay? Is that okay? It kind of helps. And then how many electrons have I just used? 5 times 2 is 10. So I've got 4 more to place. I'm going to stick them on my oxygen. There's my Lewis structure. Okay? So tomorrow in class, I'll have something ready for you to play, and it will have formal charges,
What? Play.
formal charges, and why TBS doesn't apply to everything.